This video is about how to find the points of intersection of lines and circles. So imagine that you have a circle and you want to find where a line intersects it. There's a couple of different possible outcomes. The line may intersect the circle in two different places, in which case you have 2 points of intersection. The line may intersect the circle in one place, or at one point only, in which case it is a tangent. Or you might have a third case of a line that doesn't intersect the circle at all, in which case you have no points of intersection. The two cases that we're going to encounter on the Leaving Cert Ordinary Level course are the cases where a line intersects the circle in two places at 2 points, or where a line is a tangent and just intersects at 1 point. So let's have a look at an example. So here's our example. Find the points of intersection of the line x plus y equals 7 and the circle x squared plus y squared equals 25. So these are the two equations that I'm working with. I start off by taking my line equation, x plus y equals 7 in this case, and rewriting it so that one of the variables is by itself on the left. Now this can be x or it can be y, whichever is most convenient. Here it doesn't make much difference because x and y both have a coefficient of 1. So I'm going to get x is equal to. So step 1, I rewrite the line, and in this case I get x equals 7 minus y. Step 2 is going to be to take this new version of the line and substitute it into our circle equation. So I know now that x can be written as 7 minus y. So whenever I see x in my circle equation, I'm going to replace it with the 7 minus y. And I can see that here at the start of the circle equation, I've got x squared. So I'm going to want to say 7 minus y squared. Make sure to put it in a bracket. So this is how my circle equation will look when I've replaced x with 7 minus y. And now the obvious thing to do here is tidy up. So I've got 7 minus y by 7 minus y. And I want to multiply this out and tidy it up a little bit. So pause the video at this stage, do that yourself, and then play and check and see if you got the right thing. So I've done a bit of tidying up there on the left hand side. And you can see at this stage that it's starting to look like a quadratic. So I'd like to rearrange it even a little bit more to make it look like a quadratic that I can solve. So I know that that means I have to have it equals to 0. So I'll bring everything to the left and I'll put everything in the correct order. And again, pause the video at this stage and see if you can do that yourself. So my quadratic now looks like this. Step 3 is going to be to solve this quadratic. And just before I begin to factorise and solve, I'll just see is there anything that I can do to make my life a little bit easier. And you might notice in this case that 2 is a factor of each of these values, so I can divide that quadratic across by 2. You don't have to take this step, but frequently it'll make it easier to solve the quadratic. So you'll end up with y squared minus 7y plus 12 equals 0, which you then have to factorise. So pause the video for a moment, factorise this quadratic, and then check and see if you got that right. So the quadratic factorises as y minus 3 by y minus 4 equals to 0. And then don't forget, to solve, all I have to do is let each of those brackets equals to 0 and figure out y. In this case, you get y equals to 3 and y is equal to 4. Now let's just think back to the diagram that we had at the very beginning of this video. So we had a circle and we had the possibility of a line cutting through it in two places. And that's what's going to happen in this particular question. Well, just think about these 2 points for a second. Don't forget that every point is made up of an x and a y part. Now I've got 2 y parts. That's for these 2 points in my diagram here. So now I need to get the 2 x parts to go with those. And when I have that, then I'll have the 2 full points where the line and the circle intersect. And to get there, all I have to do is take my 2 solutions for, in this case, y, and sub them back into my line. And it's actually easiest to go back to your step 1 at this stage, which is nicely set up to let you work out x. It tells you x equals 7 minus y. So if I sub my y's in there, it'll tell me exactly what x is worth in each case. So let's start with y equals 3. So in that case, x is 7 minus 3, which means that x equals 4. Now I want to put this x and y together to make a point. Don't forget, the x always goes first. So I've got a point 4, 3. And now I need to use my y equals 4 value as well. So when I sub that in, I get x equals 7 minus 4. And that means x works out as 3. And then again, I put my x and my y values together to make the point. And now here I am, job done. I have 2 points, 4, 3 and 3, 4. And those are the points at which the line cuts through the circle. So here's a second example to show that the line x minus 3y minus 10 equals 0 is a tangent to the circle x squared plus y squared equals 10, and to find their point of contact. So note the word tangent here, and if we refer back again to our earlier diagram, we remember that a tangent is a line that meets the circle at one point only. So if we can find the point of contact and show that there's just one point of contact, that in itself shows that the line and the circle, that the line is a tangent to the circle. And the steps that we go through are the exact same as in the first example. So step 1, I'll start by rewriting the line. And it might be a good plan actually at this stage for you to even pause the video here and, having looked at the first example, see can you work through the second example yourself, and then play the whole thing through and check and see if you were correct. Or if you get stuck, play it up to the point where you get stuck to give yourself a nudge along in the question. Okay, so I'm rewriting my line, and I'm going to get the x by itself. And you can see here that the x is the sensible choice for getting by itself in this question because there's no coefficient in front of that x. Or it's a coefficient of 1 if you want to think of it that way. So I simply have to move the 3y and the 10 across, and that's it, then x is by itself. Now, next I'm going to rewrite the circle. So I'm going to take the circle equation and sub in this case, 3y plus 10 for x. And again, don't forget about the brackets. It's important to remember that when a bracket is being squared, I have to multiply the full bracket by itself. So don't forget to work that out fully. And then I'm going to begin to arrange it so that it looks like a quadratic. Just tidying up on the left-hand side first, remembering that I need to have it equals to 0. And I end up with 10y squared plus 60y plus 90 equals to 0. My next step is going to be to solve. And of course I can make this process a little bit easier for myself if I like by dividing if that's possible. So having a glance there at my 10y squared, 60y and 90, I see that 10 will divide into all of those. So I'm going to take advantage of that and divide across by 10. And I get 1y squared plus 6y plus 9 equals to 0. And now I need to factorise that. And at this stage it becomes apparent that, okay, well my two factors are the same. So that also means that my two solutions are going to be the same. So I'm basically getting the same point twice. I'm not quite finished yet, I haven't got my full point, but I do have the y values, and the y value is repeating itself. Now, I'm not overly surprised at this, because at the beginning of the question, the word tangent was mentioned. So I kind of expected that I would only be finding one point of intersection. And that's what this repetition is telling me down here, but I'm going to just get 1 point. So now I'll finish up with step 4, which is subbing my y value back into my line from step 1. And so in this case, when I sub in minus 3, I'm going to get x equals 1. And I get a point of contact of 1 minus 3. Don't forget that x value goes in first and the y value goes in second. I was asked as part of the question to show that the line was a tangent to the circle. We're doing that by solving and finding that there's just one point of contact. And there's no harm to actually point that out at this stage here. So it's a same solution, or repeating solution if you like. And that means we have a tangent. And the point of contact that we were asked about then is that final point 1 minus 3.